Hello 8th grade, this is Mr. Rogers, and you are watching the video lecture for section 2-1 in your book on forces and describing forces. So this first page is our lesson objectives. You do not have to write this down, but kind of what's coming up in this first lesson here. So we want to be able to explain balanced and unbalanced forces, kind of one simple thing, kind of laying the groundwork. These first sections tend to lay the groundwork for later on in the chapter. And secondly, and there's going to be a few of these, we're going to spend most of the chapter talking about this guy, Sir Isaac Newton. So our second objective today is to interpret Newton's first law of motion. What does it mean? How does it work? Those type of things. So first off, we're going to talk about the nature of force. And what is a force? When you think of a force, I want you to think of a push or a pull. It's pushing or pulling on an object. So pushing or pulling on an object. And something, when a force pushes on something, if there's more than one, that greater force, when they're all balanced out, will cause that object to move. So forces in the same direction add together. You think about if you have a headwind or a tailwind while you're running. We talked about that before in class. If you have that tailwind and it's pushing you from behind, your speed, your force, and the wind's force would be added together. So the idea of net force is when we add these together. It's the overall force on an object when all forces acting on the object are added together. Is that net force? And I like to think of like a paycheck. When you guys start working in a couple years, you'll get your paycheck and you'll see your pay. You'll see your pay after taxes and everything gets taken out. That's your net pay, which you actually take home. Your net pay after everything is taken out for taxes and everything else is configured. That's your net pay. I think that in terms of net force. After everything's added and canceled out, you have your net force. So what this can create is an unbalanced force. And we spend most of our time in this class talking about unbalanced forces. There may be a couple forces acting on an object, but overall there's an unbalanced force. It's being pushed or pulled in some direction. It is actually moving. So an unbalanced force, the big word here is that does change an object's motion. It's going to cause it to start, stop, or change direction. So it's going to cause it to accelerate. That word from last chapter keeps popping back up there. So on the other side of that, we have balanced forces. A balanced force, they're equal forces acting in opposite directions. So it doesn't change an object's motion. And when we think of that, I want you to think of, we have a picture here of it. We've got, an unbalanced force. The guy's pulling himself up. Looks like it's me doing some bench presses there. A couple 45s each side, normally what I do. And here, a tug of war. This would be an example of a balanced force. So kids are pulling this way, kids are pulling that way. We have our forces kind of balancing or canceling each other out. So it's a balanced force. Each person is not moving. So unbalanced, the object moves. This guy's pushing the box, pulling or pushing up weights. And we have our balanced force where they're pulling. They're both pulling very hard, but they're a balanced force, so they're not moving. That's it basically there, guys. We hear a lot of a balanced or unbalanced force, and that's what it means. Balanced, not moving. Unbalanced, it's going to be moving. So you still have a force. You're still acting on it. These kids are still pulling. They're just not going anywhere, so it's a balanced force. Now, our next topic, guys, is going to be on our first law of motion, some Newtonian physics here. So the next couple days, this really most of the chapter, is focused on this guy here, Sir Isaac Newton. Sir Isaac Newton lived in the 1600s and the 1700s, and he's pretty famous for kind of discovering, or most famous for the idea of discovering gravity. I wouldn't say he discovered it, but he applied that universal theory of how gravity actually works, how it works on planets. He did a lot with how the planetary motion, and he actually invented his own math to prove that the planets are actually moving around the sun. He invented a type of calculus that could actually mathematically prove how the planets are moving around the sun and actually calculate distances between planets with his mathematical formulas and how things are traveling. So a pretty intense guy. He did a lot of things. The idea of gravity is just one. That universal gravitation is one. These laws of motion, another one. He did things with improving telescopes, those type of things. So there's a lot of things on his resume. One of those very important guys we learn about in science here. So his first law of motion is based around the idea of inertia. And inertia is the tendency of an object to resist a change in motion. So resisting change in motion, what does that mean? Well, that means if I'm moving, I'm going to keep moving. I don't want to change my motion. If I'm stopped, I want to stay stopped. I don't want to change my motion. So it could be either or. It could be if you're moving, you want to keep moving, or if you're stopped, you want to stay at rest. And so that's how we kind of read Newton's first law of motion. Here's our big idea, really the really big idea of the day. First law of motion states an object at rest will remain at rest. An object moving at a constant velocity will continue moving at a constant velocity unless acted upon by unbalanced forces. So a lot going on here. So things that are moving want to keep moving. Things that are stopped want to stay stopped. Unless, again, those forces, those pushes or pulls, unless those unbalanced forces act on them and cause them to change their motion. Now, we've all experienced inertia. We've all experienced this. If you're a skateboarder and you hit that pebble or rock in the road, your board stops and you don't, again, you're in motion, you want to stay in motion. If you're ever on the school bus and it stops suddenly, and all of a sudden your face is planted in the seat in front of you, again, you're in motion, you want to stay in motion, so you kept sliding forward into the seat and back you. And there's hundreds of other examples like that. Those two kind of simple ones that you have inertia. Now, things that can affect inertia. There's one really big thing that affects inertia, and that's the idea of mass, the amount of matter that an object has, or is in an object. And the greater the mass, the greater the inertia. So the greater the mass, the greater the inertia. So once you get that truck moving, it wants to keep moving. Once a truck is stopped, it wants to stay stopped. So the greater the mass, the greater the inertia. It's harder to get moving, and it's harder to stop the bigger the object. We'll talk more about that in class as we go on. That's kind of the basis of it, that mass really does affect an object's inertia, or the resisting that change in motion, right? So, 8th grade, thank you for watching. We're going to stop here today, and we will see you along the way.